Hello, everyone. Welcome to another episode of the Monthly Dev. Thank you all for joining and coming to have this pleasant meetup together with us. And for those of you who don't know the Monthly Dev, it's obviously a monthly meetup that we host. It's free for all. It's virtual, so you can tune in wherever you are in the world. And we try to bring world-class speakers to talk about everything that's hot in web development, architecture, backend, data, and everything that has to do with software engineering. If it's your first time, make sure to subscribe to our YouTube channel, Twitch, every favorite platform that you would like to watch us. We are there, so just subscribe to make sure you will get notified on our upcoming events as well. Let's see who is going to talk today. So here is the lineup. We have Dustin from this dot who is going to show us the power of GraphQL and how it's like in the enterprise world. We have Oded from EverSQL to share the greatest and bravest tips about SQL queries after lots of data analysis that they did on many SQL queries. And then lastly, we have Alejandro from Tinybird, who is going to show us how to create real-time application and analyzing millions of records using Tinybird. And before we jump into our first speaker, to Dustin, we want to give you some swag. And in order to join this raffle, all you have to do is open your favorite social media, drop the YouTube link, Twitch link, whatever. Make sure to add the monthly dev hashtag to your post, and we will pick the 10 most creative shares, and we will send you a snapback for free. So just make sure to keep your DM open, and we will contact you, and we will watch all your shares, and we look forward to see them. So this is the perfect time to go ahead and do this right now. And without further ado, let's start with Dustin. So please welcome on board Dustin from this dot. Hey, Dustin.
Hey, Ido, thank you for having me.
Thank you for coming. How are you doing in this lovely day?
Oh, it's a beautiful day. It got a little chilly here, but loving the weather. Excited to be here to talk about GraphQL, though.
Super. Are you ready?
Yeah, mind throwing my slides up?
Yeah, let me do it. Okay, here it is. So good luck, Dustin.
Thank you so much. Well, hi, everybody. Really excited to be here. Today, we're going to talk a little bit about GraphQL and how you can leverage it to upgrade your stack and use it in the enterprise. Before I get fully started, a little bit about myself. My name is Dustin Goodman. I'm a engineering manager at this.labs. We're a JavaScript consultancy, and I get the lovely opportunity to come and speak at events like this as well. You can find me on Twitter at Dustin S. Goodman. Um, some of the cool things we kind of do. We get to work with some amazing clients. Recently, we've gotten to work on projects like the Facebook React documentation, as well as some other big conference platforms that you may have accidentally integrated or used along the way. So lots of fun things. And what's really cool about some of these applications we've been building is that we've been using GraphQL specifically to help solve some of our performance issues as well as some of our scaling issues. So today we're going to talk about a few things. First is kind of broadly, what is GraphQL? And then I want to talk a little bit about how GraphQL compares to REST. After that, we're going to talk about why some organizations are looking at GraphQL over REST. And then finally, going to explore the GraphQL ecosystem kind of at a high level. Don't have a ton of time, so need to be very careful about how much we talk, but you should definitely look at all these tools in further detail. So to start, what is GraphQL? And simply put, it's a query language for your API. So in the traditional REST sense, we make a bunch of requests, we get some data back, and we have to know our REST verbiage on what actions we're doing. Well, GraphQL on the other side gives us a lot more control and lets us understand what that data is through statically typed fields. And what's really awesome and powerful about this is it gives consumers of your API full knowledge on the type of data they can use, as well as how to do certain operations like retrieving data, manipulating data, or listening to changes on some of that specific data. And this is incredibly powerful because it's going to let you, as a consumer of an API, be more particular about what information you need to be gathering or what information you need to be providing to an API in order to fulfill a request. And so this is going to give us several advantages over REST, and that's why we're one of the many reasons we're seeing strong adoption across the enterprise. Um, and definitely one of the big impacts is this is really going to help, and we'll see further down, it's going to help lower the overall communication barrier between your API and your client teams, as there's going to be less conversation about the shape of the API after it's been built and more about it before it's been built. So first off, it's important to acknowledge that one of the most expensive and resource intensive, as well as time consuming parts of any client to API communication comes from the HTTP request and the response process. Um, and having that knowledge, we can talk about some of maybe REST pitfalls that GraphQL is seeking to solve. Might not necessarily solve on its own, but definitely something we need to consider as we're looking to adopt GraphQL. So let's start by looking at an example of the declarative nature of GraphQL queries. So in the example here, you can kind of see on the left-hand side, I've created very simple user query using GraphQL syntax. If you don't know GraphQL well, uh, this is just a general operation with a name that operates in a specific way, taking whatever arguments and provides exactly that data back. Now, what's really powerful about this is, as you can see on the left, I've structured the query to request exactly user1234's ID, name, email, and role. And what you can see on the right-hand side is the way in which I requested my data almost perfectly matches the way that I received my data on the other side. So what's what's so important about this? Well, this is indicating that we not only as the client consumers have the power to indicate what data we want and nothing more, but also gives us the power to specify in what shape that we get it back, really reducing our mental model around how we're going to dig deep into data and access how it needs to be utilized within our components, within our applications, etc. So let's talk about one of the great benefits that this provides, which is it helps solve REST's underfetching problem. So in traditional REST, one of the major issues we have is we can't get relationships super easily. So in this case, let's say we have a very strict REST API that's one resource per endpoint. So let's say we have a user and their comments. Well, if we want to get those comments, what we're going to have to do is we're going to have to make a request for the user, and then we're going to have to make an additional request to go get the comments. So we're going to have 2 round trips to our server, causing a lot of time kind of wasted in that HTTP cycle. Well, on the other side, then let's say we make our REST API a little more extensible and allow it to take maybe query parameters that allow you to expand the result so you can get the user and all of their comments. Well, this is going to cause the other side of the problem where now we're going to maybe fetch way more data than we need. And so on the other underfetching side, we're wasting a lot of time in HTTP cycles. Whereas on the overfetching side, we're losing time in a single request and maybe getting superfluous data that we don't necessarily need. Um, in fact, to talk about this overfetching problem, I like to tell about a story that of a problem that I faced in a real production site. We were migrating an old REST API to GraphQL for this exact reason. Uh, we had a page that was actually fetching literal megabytes of data, about 20 megabytes using the old REST API. And what we actually found is once we kind of switched over to GraphQL, reduced the overhead of all of the data we needed and got it down to just the slice of data we needed, we were only truly using about 200 kilobytes of that 20 megabyte payload, meaning our users were suffering a terrible experience as a result. So this is definitely something you want to be paying attention to as you're building your APIs, as you're thinking about performance. So while this might not solve all of your performance issues, it might aid you in certain areas that you might not have been thinking of or looking at more strategically before. So to kind of demonstrate this problem more visually for those of us that like to see the code instead, uh, right here, this is what a traditional REST request might have looked like. If I wanted to, maybe the use case here is I'm trying to get a user and I want to display their last comment and their last post. In this case, what I have to do is on the user, I'm now running an expand to now get the comments and the posts for that user. But now I'm going to get all of that extraneous data because I can't filter on comments or posts. So at the end of the day, I'm just getting a large list of all of that data that I'm not necessarily using. I'm only using a couple of those data points that are being returned. Well, switching to GraphQL, what we can actually see is GraphQL allows you to pass in arguments into your different fields that you're passing in your operations, which means comments and posts here, I can actually, if I build my API to support it, I can actually support limiting and sorting directions directly into those fields and only fetch that single piece of information that I need. Um, so what we can see here is that we're going to be able to just get that exact piece of data that we want on the right-hand side as the output. Now, you might be thinking, oh, why would I want to do it that way? Wouldn't I just create a field called last comment or last post? Well, you absolutely could do that. I decided to demonstrate it this way just to kind of show parity between two existing APIs. But if you really wanted to get down into the nitty gritty of it, this is definitely something you could explore doing in your implementation. Another great solution that happens, or another great problem, I should say, that GraphQL seeks to solve is the all or nothing problem. I'm sure many of us have written REST APIs where we've gotten 400 or 500 responses from the API and couldn't do anything with the data because we got nothing back. So we had to display a 404 screen or an error loader or some different type of error handling that had to be a little disingenuous to the intended user experience. Well, what GraphQL does is it actually returns both the retrievable data as well as all of the errors that occurred. So now instead of fully blank pages or having to be disingenuous to the user experience, we can actually tell them exactly where the errors fell or how we could actually look at some of the data as it went. Um, in contrast, just to show, this is what our REST API would have kind of looked like, or sorry, our GraphQL response would look like in this example. So here I requested kind of users and comments, again, kind of following our example from before. But what we're seeing here is comments is actually erroring out inside of the response. And so I'm not able to fully engage with that information. Kind of stinks, but I'm still able to show the user some of the information I tried to retrieve. Additionally, if I know kind of what is causing this internal server error, I could make that error message a lot prettier and make it something I could display to the user in a more intentional way and give them that better user experience overall. What's even cooler about this feature, though, is in development mode, if you're using something like Apollo Server or any of the other GraphQL implementations, what you can actually do is provide stack traces into this error key and actually pass that back to your backend engineers so you can work together to resolve the issue that you're seeing. You'd be like, hey, here's my exact query I ran. Here's the headers, everything I used. And then here's the exact error message with the stack trace in your code that maybe you can use to go resolve this, which makes the internal development cycle a lot more tighter. It lets you resolve problems faster than before because now you don't have to have a third party bug tracking tool, or you don't have to start from the initial endpoint and work your way back. Another great feature that GraphQL gives us out of the box is batch requesting. In REST, there is no way to do a batch request. You have to create a custom endpoint that handles this. You usually have to do some background processing. There's a variety of different things that you would have to do to make this work in a traditional REST ecosystem. However, GraphQL lets you do a bunch of operations simultaneously. And this is really great for pages like dashboards, where you're retrieving a ton of data, aggregating it, and displaying it in a multitude of sources. The one downside, though, is that this can still cause some slowdowns because you're fetching a lot more data, kind of like I mentioned earlier. We had that page where you're getting 20 megs of information. You want to be careful because batching can lead to the point where you're starting to get way too much information again. So what we recommend is definitely avoiding doing these types of operations on the client side, but save them for your server side renders because what you'll see is some of your server rendering will be much better. And I don't know if anybody saw the remix announcement this week, but definitely something I want to be looking into with GraphQL and see how we can leverage the GraphQL ecosystem with things like remix to build even more elegant applications in the future. So in just to kind of show GraphQL batching quickly, on the left, I have another operation similar to the one that I had previously. So I have my user like I had, but now I'm also requesting a sales dashboard and a marketing dashboard with parameters. And as you can see, each of those requests is a different query against my GraphQL API, but I'm getting all the results in a single go. And this is really powerful because now I don't have to make those three separate requests. It's a single operation to the API, one round trip. When you have tools like Apollo in your ecosystem, and we'll talk more about that later, some of this batching can actually be done for you automatically if you do your configuration correctly. And this is just super incredibly powerful because now you're just reducing your overall time on the wire between your server and your client, giving your clients a lot less time spent fetching and retrieving data, better for their bill, better for their user experience, also better for the speed of your site. So now that we've kind of explored some of the problems GraphQL is trying to solve, let's talk about why the enterprise is really starting to adopt it. First and foremost is a huge separation of concerns. One of the things that GraphQL is really great at doing is it's really great at sitting between all of your APIs and all of your clients and acting as kind of a middleman between the two sides of your application. And so previously we might have had multiple microservices with their own unique authentication patterns, which isn't super great for performance. Now our client developers have to determine how to use each of those different operations to get authenticated and make requests. Well, with this single layer, we're able to consolidate all of that information into a single home and allow users and developers a unique experience for accessing and fetching data. And this is going to be great because it's going to allow you to create a lot of flexibility when developing the API, but also allow you to scale in whatever way you want. This is a great way to actually adopt a microservices architecture if you've been on a long-term monolithic application and you've been looking at maybe breaking things down, or if you're just not ready, definitely just stay in GraphQL and work within your existing monolith and just see some of the power that it extends you in letting you make some of those bigger changes without making drastic changes to your API layer itself. We recently used this exact pattern on a recent project because we had a backend service we were integrating with that was ever evolving. And because our layer between GraphQL and the client was consistent, it was really nice that any changes between us and that third party system were easily manipulated and changed to meet the existing business need of the client without changing the outcomes of the project itself. So, definitely something to think about as you're developing new applications and adopting GraphQL. Another great thing that we've been seeing is just faster prototyping and development with GraphQL. With the GraphQL adoption approach, what you can do is actually build your schema first. And we'll talk about that when we talk about migration patterns in a minute. And what's really fantastic about this is you can start defining every GraphQL API by defining its schema, which is going to define all the types it supports, all the operations it supports. And rather than having to just go and actually build out APIs, what you can actually do now is just provide dummy JSON data to those endpoints very easily. And once your backend is caught up to your API layer, you just flip out that layer and your client side applications don't have to make any changes. Your server side application just has to make the change to switch out the data, and nobody's the wiser. You could be using dummy data in production today and you wouldn't know any better because things are still going to be working. And this is really great for adherence from both the client and API teams because now what they're saying is, hey, we're agreeing to build this thing. This is how we're going to do it. And there's no more, oh, I had to make this drastic API change all of a sudden. Hey, client developers, can you go make those changes? Now you fit the changes into the model that you've agreed upon, or you discuss ways to extend that model to be more conducive to that conversation. Another really great thing that GraphQL supports kind of out of the box is component-driven architectures. A lot of us are building Angular, Vue, or React applications these days, or you might be using something else, but the three main popular ones right now. And you all might be trying to keep the data as close to the most relevant component as possible. But sometimes we're building these REST requests that need to be brought up to a top level layer, set into a global store, and managed that way. Well, with GraphQL, it allows us to define exactly how that data should be fetched at the specific component level. And then if you're using tools like Apollo, you can actually lift some of those subqueries up to a higher level, batch them, stuff them into your global state and context, and then fetch them back out using those same operations in a very great way. And what this does is it allows you to create more stateless components that can just understand how they're going to ingest data from a parent component that is providing them that data. Another really great thing about GraphQL, and another reason people are really loving it, is the strong typing system. We've seen a big shift from JavaScript to TypeScript in the last few years, and with GraphQL, we're seeing kind of a great way to further that integration. When you're defining your schema, you're also defining that GraphQL has specific types, and it gives you this strong typing system that allows you to really understand the type of data you're interacting with, which is also great because how many times have we had to go and read a REST API documentation that says, yeah, just send me this type of data back, and you go scrunge around for a little while and still can't figure out the exact shape of the data to get the exact result you want. GraphQL is great in that it'll inform you exactly what those shapes are and exactly what those data types are. And it also gives you the ability to define those types even more strictly. So if you have a date object, for instance, that you want to be sent in a specific format, you can actually type your fields in GraphQL to only behave and accept that exact format and give users the information they need to know that's the format they're expecting. So now that you've kind of seen some of the advantages of GraphQL and you've seen some of the reasons that enterprise is adopting it, how are you going to start adopting it today? And the answer is going to be you want to start by one, having a conversation with your team to make sure you actually want to adopt GraphQL. Once you get over that hump, though, you're going to want to have the conversation of what should our schema be? And this is definitely a longer conversation. It's going to take more thought. We recommend starting with a small slice of your application, one that doesn't touch a lot of the system, just to see some of the basic power of the u- the tool and utility. I don't have a lot of time to go over all the syntax here, unfortunately, but to kind of highlight some of the things is GraphQL is actually built upon a graph data structure. So if you look in my example on the left here, I have type and user as two custom types that I've created into my GraphQL schema. Now, more specifically, you'll see that user and comments are defined in each of those objects respectively, and they're defined using each other. Now, you might think this is a circular dependency, but because of that underlying graph data structure, we're able to have all of these cyclical relations between entities, allowing us to have these really rich understanding of our data and how they're interrelated and how they relate back to one another. And this is going to be really powerful because as we get down to defining our special types, our queries, our mutations, and our subscriptions, by the way, GraphQL ships out of the box with socket subscription support. You're going to have things like users and user queries that you now can operate with, fetch that data, and then define how you get it. Now, the next question might be, well, how do I determine how from the schema I'm going to get the data? And that's where the power of resolvers is going to come. Resolvers are going to be responsible for fulfilling any given request uh, given the schema that you've defined. And what's really powerful about them is they're just functions in JavaScript, and they're asynchronous. So you can do whatever type of data manipulation you want. Want to access it through a service layer? Fine. Want to use a database directly? Fine. Need to make an HTTP call to another service? That's fine by us. Using uh, gRPC? Fine. You the world is endless. You have a number of options. Definitely feel like you're not limited because resolvers are going to let you do all sorts of things. Another great thing that resolvers do is they'll let you manipulate specific field data itself. So to look at an example of that, what I have here, this is an example from Nest.js, where I've used some of their kind of directives and decorators to define a very simple resolution for that API I showed you previously. So in this case, for users and my user query respectively, I'm just using a simple HTTP request because I'm migrating from an old system. I don't have time necessarily to port all of the backend logic to support this existing system, and I just want to get my proof of concept up and working. So as you can see, HTTP is a perfectly fine protocol for this. It might be a little slower than some of the other protocols out there, and you might see a performance hit for doing this, but it's definitely something where your servers are probably closer together than your client is to your servers. So you're still going to see a benefit to doing it this way. The other really amazing feature is, let's look at this comments at the bottom. Now, comments isn't related to a specific query, but it's related to a field on user. So in this case, a user has many comments. And the way that we're deciding to resolve this is through, again, another API request. And the way GraphQL is going to resolve this, I don't have time to go in this in detail, but it's going to resolve it down a tree. And so each request will have a subsequent result. And this is going to batch as much of the operation on the backend as possible, and you're not going to see an immense slowdown as a result. Now, additionally, this ability to resolve a specific field isn't limited to just fields that have one-to-many relationships or many-to-many relationships. This is also related to the ability to relate between single entities. So let's say you have a telephone field or an email field, and those have very specific formats associated to them. You can actually write a resolve property function that now manipulates that exact data, however you store it into your database, and makes it more human readable for the API in whatever format it needs. So don't feel like your data needs to be perfect in your database. It just needs to be perfect by the time it reaches the GraphQL layer itself. So in migrations, the goal is to allow teams to communicate to define and build out the schema. And this build out is occurring and the middleware is being developed. Clients can start to begin adopting and utilizing this layer with ease, which is really great. So I don't have to wait on the back end to fully develop this GraphQL schema before my front end can be updated to start using the same thing. All you need to do is you just need to create that schema and have that GraphQL endpoint stood up that's serving at least maybe dummy data that now both teams can start integrating with and updating so things just work in time and productively. And this is really just going to increase your overall developer productivity engagement because they're going to be more invested in decisions as they're being made. Um, So that you've kind of seen how GraphQL and the business reasons why you might want to be using it today. One of the greatest part about GraphQL is actually its growing ecosystem, and I won't have time to delve into all the great things here, but I want to highlight some of the best and greatest things that you might want to start exploring yourselves today. The first is Apollo platform. Now, Apollo, you all might have heard of them. They're becoming more synonymous with GraphQL every day, but they're not the only players out there. They're definitely one of the most popular ones, though. And Apollo's done a great job of providing both Apollo Server and Apollo Client as open source projects that we can integrate into our code bases today. And Apollo Server is going to help you really build out your graphs schema and how you're going to integrate with all of your sources. And it also ships with some really great tooling, specifically REST data sources. The way I showed you all how I was doing data REST calls in my resolvers previously is a way you could do it, but you'd also use Apollo's REST data sources, which has an optimization for batching requests, so you don't double down on the same request when your tree of your query is trying to resolve. It's a really powerful tool and one you should definitely consider using. Federation is another amazing tool that they've really improved this year. And the point of Federation is for you to build multiple microservices, each with their own unique GraphQL schema that you then stitch together and serve to your clients and let them consume it. Apollo Platforms, Apollo Client on the other side is going to be kind of your consumer of that, and they have amazing front end specific libraries for React, Angular, Vue, and what's amazing, the most amazing part about this is it has some of that state management I started alluding to. So when you make queries and operations through Apollo Client, what you'll actually see is the data is then stored into the global cache and then retrieved out of the cache by your queries itself. So if you have multiple requests going on in a single component or across multiple components that share some of that same data, you'll see you're seeing less requests go to the server specifically and a lot more coming in and out of your local cache. So this is definitely a set of tooling I highly recommend you look into. Another great tool chain that a lot of people have been using to at least prototype and are starting to see use in production is AWS Amplify and AppSync. AppSync is a great way to uh, quickly create, configure, and deploy all of your applications, resources in the AWS cloud using your GraphQL schema as the source of all of that. And then Amplify is a great way to deploy your front-end application and connect the two. So this could be another great tool that your team may want to consider. Of course, I need to talk about Hasura, especially since we're talking a lot about SQL today. Hasura is a great way to connect your database directly to GraphQL and build out your whole schema for you. It currently supports Postgres and Microsoft SQL Server, but they're also coming out with a lot of support for new databases. I think they recently came out with BigQuery, and they're working on MySQL for hopefully early next year. So definitely something else to look into. And my favorite feature of GraphQL is GraphQL Playground. I wish I had more time to demonstrate it. I have a brief demo where this is the Star Wars API. You can Google it very easily. I can also share the link in the chat later. But what's amazing about this is GraphQL is self-documenting. So as long as you're writing comments as you're going, what you'll see is you'll be able to explore your full schema and understand what all of the different uh, application nodes are and how they're shaped. So in this case, a film might have a title, an episode ID. It also has a connection to planets and characters. And so you could start writing a very simple query over here on the left-hand side. And I'll try to be quick about this. So this should just be, if I go to all films, it's going to just give me, I want the films inside of it. And let's just say I get the ID, the episode ID, and the name, or the title, I guess is what it is. And what you can see very quickly is I'm going to get the database ID as well as what episode and the name of the movie. They don't quite have all the new movies yet, but they're definitely coming in, as you can see. So definitely a way you could start utilizing GraphQL in a very powerful way, and you could start seeing how some of these cycles could start behaving. Don't have quite that much time for that demo. Want to respect the other speakers' times. Um, but yeah, that is everything I had to present today on GraphQL in the enterprise. If you'd like to learn more, definitely feel free to reach out to me on Twitter. My Twitter handle again is Dustin S. Goodman. And it's been a pleasure talking to you all today.
Dustin, thank you very much for the talk. Actually, I wanted to share that we use GraphQL on daily.dev for a while now, and it's super awesome. Like you mentioned developer productivity, and we definitely feel it much easier, to build the APIs and then use them on the front end. So I highly recommend it.
I agree. We our biggest achievement, we one of our big clients that we just built a GraphQL API for, we were able to actually, because of our caching strategy and all that, support over 20 million requests in 2 days.
Oh wow!
Yeah, so it definitely has all the scaling possibilities, and we had a very strict rate limit with one of our provider services. So being able to really control that interaction was amazing.
Yeah, I agree. So thank you very much for the introduction, and talk to you soon.
All right.
Bye.
Thank you. Bye.
Bye. For our next talk, I would like to invite Oded to our virtual stage. So please show your love to Oded in the comments, and he's going to show us some tips about SQL. So, Oded? Oh, 1 second, you are muted.
Hey, hi Ido. How are you?
I'm great, thank you very much. How are you?
Good. Excited to be here.
We are super excited as well to host you. Thank you for coming. And let me share your screen. Okay, so are you ready?
Okay.
So good luck. Let's do
Cool.
it.
So hi everyone, and thanks Ido and the Daily Dev team for hosting us. We're a big fan of the Daily Dev. That's my favorite tab on the morning. So guys, this session is going to be a little bit different. It's going to be interactive. So Avinash, Vishal, guys, are you ready? So let's do it. Please raise your right hand for a second. Don't be shy, nobody sees. And your left hands as well. Not if you are driving. Cross your fingers, put it behind your hand, stretch. It feels good, right? This is usually how an engineer looks like when he runs a query and waits 1 second, 2 seconds, 5 seconds, 1 minute until he gets the results. And we see it on a daily basis. So again, hi everyone. My name is Oded, and I'm the co-founder and the chief product officer of EverSQL. If you haven't tried it, this is the first ever AI-based DBA. It's been used by more than 70,000 developers across the globe. You can imagine as the best DBA in the world sits next to you, kind of Grammarly for SQL. Really cool. And what I'm going to share today is our practical advice for writing faster SQL queries. In the end of this session, you will get a few tips on how to write better queries. And you think to yourself, why this guy can tell me about SQL? It's not because of me, it's because our engine already analyzed more than 1 million queries by more than 70,000 developers. And we ran more than 1,000 different optimization algorithms on those queries, rewrite those queries. And for this session, I looked for the patterns that are repeatable, all the mistakes that developers are doing again and again and again. And I decided to bring them together and share what are the top mistakes developer makes so you can learn and don't do them. So let's start. You know your friend that usually sits next to you or with you in the Slack, and you're telling him, hey, I have some database performance problem. And he looks at you and he's telling you, dude, you have database performance issues. What, are you kidding me? Just let's buy bigger instances. Let's throw more money and get more RAM, more CPUs. So yes, from our experience, that can maybe help for a few hours, but this is not solving the root cause of the problem. It's just a band-aid on the issue. So I gathered 5 things that you can share to this friend, and you can tell him next time he's telling you this. It's called focus. Focus. You can tell him, go focus. And let's start with the first tip. So the first thing is related to functions and indexes in SQL. And for that, we are going to do something interactive. Are you ready, guys? You can use the comments to participate. So welcome to the Which One is Faster show. So I'm going to show you 2 queries, 2 SQL queries. Don't rush to analyze them. They are both doing the same thing. Let's say that we all have an e-commerce business for selling frogs dolls, of course. And I want to know how many frogs I sold in 2020. So on the blue side, I have one query, which is select count everything from frog purchases where purchase at, which is a date, bigger than the beginning of 2020 and smaller from the end of 2020. So this is one query. On the green side, I have a similar query that will bring me the same result, but I'm doing something which is more efficient, where I say where year of the purchase at, I'm using a function equal 2020. Who thinks that the blue one is faster? You can write blue. Who thinks that the green one is faster? Blue, green, blue, green. Okay, so I see here a lot of blue. So yes, the blue one is faster. And the reason for that is that when you use a column in its original format, the optimizer of the database, which is the engine that analyzes how to execute the query, is able to use indexes. So in case there is an index on purchase at, the database can use it and just bring the relevant columns. When I'm using the function, it might look simple, but the database in most cases cannot use an index, which means that it needs to run all the rows and do what we call a full table scan. So let's even see it, because it looks so easy. So people say, I can't believe it. So here I have a database. Yeah, you can see my my dbeaver. I download the Stack Overflow database. It's a nice, if you need a nice data set, it's a good one. And here I select all the comments that are from 2012, and I'm running it. So let's run this query. You see it takes 3 seconds, 4 seconds. You can stretch yourself, and it's being executed and executed. Again, a very simple query. Runs, 14 seconds. I will show you a trick how you can identify this in advance. In the end, it will the result will come, but our goal is really in this session to make sure that those queries will take less time. So here it took 29 seconds. Here I will copy it in case you don't see the screen. It took 29 seconds. Let's do the other version where I'm using the option where I'm using the date function. Okay, I'm not using a I'm not using a date function. I'm using the field in its original format. I'm running it, and it took less than 1 second. Okay, you can see here 78.4 milliseconds. So again, just by switching and rewriting the query, you can see a huge difference. If we are here in the dbeaver, I want to give you another tip. Sometimes when you work in a database, you're not sure, is it slow? Maybe because my database is on the other side of the world, and there are network issues. How do I know if it's a network issue or it's the database? So a quick thing you can do, just select one, and then you will see how much time it takes to get. In this case, it was super fast. It was 153 milliseconds. So that means that your database is responsible. You probably cannot get queries below this time, but it means that all the latency is because of the database and not because of the issue. And again, for everyone that think that it's which database, it's MySQL 8, a very new one, but still the optimizer doesn't know how to address all those function versus real column. Cool. Ready? Okay. So I see some of the faces here telling index. I remember it's something good. Can you remind me what's an index? So let's do that. Let's say that I give you the Steve Jobs book. Here, go take it. And I'm asking you, can you please tell me how many times the word horses is in this book? So you can go page by page, nothing here, nothing here. Again, page by page. Oh, here I see one, so I'm remembering one, and then page, and all those 372 pages of the book. This is what we call the full table scan, where I need to go on all the row in my table. Where I'm using an index is the same thing like index in a book. In the end of the book, there is usually someone already did it. Look at all the words, and he's telling me that the word horses appears in page 47, 122, and 144. And this means that if I need to tell you how many times the horses word is in the book, I can say 1, 2, 3. Okay. So between you and me, what is faster, looking at the index or going page after page after page? So I'm doing this because I want you to remember how important it is that your database will use indexes, and that your optimizer, when you run a query, it will use an index. So if indexes are so good, should we create index on every column? Blue if you think yes, red if you think, green if you think no, blue, green. And the answer is no. It's no for many reasons. Indexes are great, but you cannot define indexes on everything. First, there is an overhead because every insert and every update, you need to update the index, and it takes resources. The second thing is that there are different types of indexes. You can define an index on every column. You have something which is a composite index where you can define an index on 2 columns, F1, F2. Let's say I want an index on first name and last name and phone number. And there is a difference between the order. An index on first name and last name is different from an index on last name and first name. So it's super important. So just define the right indexes. There are several tools that can do it for you for free to analyze your database and tell you which indexes are missing and which indexes are redundant. Cool. So let's move into ORM. So your friend from the office is telling you, oh, the lecture about SQL is fun, but it's not relevant for us because we are cool. We are using ORM, using Hibernate or the Django or Doctrine, and it's not relevant. For guys that are not familiar with ORM is an object relational mapping. It's meaning that instead of using tables, I'm using object, and behind the scene, there are tables. It's hiding the database layer. So is it relevant or not? Of course it's relevant because behind the scene, there are SQL, there are tables, there are indexes, and of course you can do performance improvement even if you're using ORM. What we see in large customers that they usually use ORM together with native SQL where they need performance, and of course indexes are relevant for everything. Cool, so let's move forward. We are in C, in the focus. Column data type. You're ready for another who is faster? Let's do that. So let's say that you are looking at the database of FedEx or UPS, and you want to try to understand how many packages were lost in 2020. So on the blue side, I have select, count everything from packages where status equal 5, where 5 is the status for lost. And on the green one, I have, again, a similar query bringing me the same result. Select, count everything where status equal a string of 5. So which one is faster, the blue one or the green one? Blue or green? You can write in the comments. Okay, you got me. I see that you're asking for more information. So let's say that status is defined as a varchar 255. So now, which one is faster, the blue or the green? So the green is faster. In this case, it's not even noticeable, but the idea and the concept is important. I will explain why. When you are using comparison between two different types, there is something called casting. I need to convert from the variable from varchar into int or vice versa, and it takes time. So in this case, it's probably not noticeable. But what we see a lot of time, and we found it in 40% of our queries that we analyze, is that in many times when you do a join between two tables, and in this case, I'm joining the fruit purchases and a store table, and I'm joining them by looking at the zip code. When I'm doing a join between two tables, and the column that I'm using is not from the same type, it takes much longer than if it was on the same variable type because of the casting, because of the need to convert a varchar to int or vice versa. So again, make sure that you design your database correctly. Make sure that you analyze that when you do join those columns are from the same type. You can use different tools to analyze your database and find those mismatch, but it's critical and can do amazing to your performance. Okay, two more, union versus or. Union versus or. Let's do another test. Look at the screen. Focus. Okay. So let's say that I have a database for all the audience here in the crowd, and I want to see who saw this image and yawned, or maybe is already sleeping. So wake up. So I have two queries. Both of them are bringing me the same result, but they are in a different way. The blue one is basically doing toSelect and doing a union between them. I'm selecting count everything from attendees where action equal yawning. This is one query. Union, select count everything from attendees where sleeping equal true. So I'm doing a join between two results, and only the area that is that I'm doing a simple union, the mutual area. On the green side, I'm doing it on a different way. I'm selecting count everything from attendees where action equal yawning or sleeping equal true. Who thinks that the blue one is faster? Who thinks that the green one is faster? I can't hear you. That's probably because you're muted, so just use the comments. Okay, so in this case, it's really depend on the database. Sometimes it will run the same, but in many cases, a union is much faster than an OR, and I will explain. Remember the thing about indexes? So when I'm using a union, I'm helping the database to understand that in this top query, it should use the index of action. And then for this query, you should use an index on the sleeping column. When I'm using the OR option, the optimizer might not know which index he should use, the action or the sleeping, or maybe there is a composite index of action and sleeping, or maybe it should be sleeping and action. So this is, again, very simple one, but it's really important that in complex OR, you need to help the optimizer to use the right index. So when you do a union, it's much faster and it's simpler. Let's pause for a second and say, how can I know whether the optimizer, the database, will use an index or not? There is something called explain, which is basically you add the word explain before the beginning of the query, and then the database will not run the query. It will just tell you what is the execution plan, how it is going to run. So let's see an example from our dbeaver. So remember our first query when we use the function here. So let's use explain. And when I run it, I get the result here. I'm not sure if you can see, but it's giving me just one line. When it explains how it will run, it is telling me that it will go over 22 million rows. And there are two columns here, possible keys and key. Those are the most important one to look when you run an explain plan. When I see null in the key, it means that no index will be used. And that's the reason that it takes so much time. If I will go to my other query, when I used the column in its original format, and I will run explain, you can see here that I have in the possible indexes, possible keys, a few different indexes. And here in the key, I do have an index, a name of an index. It's called comments index creation date. And therefore, I know that the database will use this index when it will run the query. So just add explain before you run the query. Okay, just to one thing if we are here, again, when you run the query, if you remember this query, the big one, the one with the year, when I ran it, it took 26 seconds, but now it takes only 7 seconds. Any idea why it's 7 seconds? Right, that's because of caching. So there are different ways of caching that you can that the database is used. There is the query caching, which you can disable. There is the InnoDB caching, which is the database memory where it's used caching the memory. But many people forget that there is also the server caching. So when you do a performance optimization and you want to make sure that you improve the results, make sure you flash the cache and don't use the cache and if needed, you restart the server. Again, 7 seconds comparing to our less than 1 second is still 7 times faster. So even with caching, when you write the query in a good format, it is much faster. Okay, the last one is S on focus signals. So besides of looking at the queries, you need to look at the resources of your database. You can see CPU, RAM, storage, and sometimes you can see 100% CPU usage, which is bad. You can use any monitoring tracking tool to track it and get it. And there are also tools to predict performance issues. But when you see that in this case there is a CPU issue, don't go and just increase everything and increase the instance with more RAM, more disk. Just use your money or use your resources correctly and just add where the bottleneck is. Okay, again, from our experience, you can achieve a ton of performance improvement just by adding the right indexes and rewriting your queries. But if you need to go to a bigger instance, just choose the right one. Okay, so to summarize, if your friend are telling you, let's buy bigger instance, you can tell him go focus, F, functions and indexes, O, ORM, C for column types, U for union or, and S for collecting signals and monitoring. That's all. I hope you learned a few SQL tips. If you have any question, you can DM me on Twitter. And I know you all guys like swag. So just for the Daily Dev, and thanks for the sponsorship, we give a credit of $99 free for using EverSQL. Just use the promo daily.dev-99. And if you have a big query, you can optimize it automatically using EverSQL. Thank you, everyone.
Thank you very much, Oded. I must say that I really loved the interactiveness of your talk. It was a breeze, and I love to see all the comments.
Cool.
You actually got me on the union and or query. So yeah, still got something to learn when it comes to SQL.
Yeah, and those are just the basic. I really took the basic one. There are really 1,000 more of different small tweaks that you can do when you rewrite query. One last thing, sometimes when you rewrite a query to get a better performance, it is less readable. And that's a trade-off that you should think about it, but you can always rewrite a query to run 10 times faster.
Yeah, definitely. And make sure to use Oded's promo code. We will share it in the comments. So if you want to try EverSQL, put daily.dev-99 and you'll get $99 to try out their awesome service. So thank you very much, Oded, for coming.
Thank you.
Bye-bye. Before we jump into our last talk for today, if you still don't know Daily Dev and you're still browsing tons of blogs looking for the news relevant to you, you use Smashing Magazine, you use web.dev, dev2, Ashnode, CSS Tricks, whatnot. You browse them every day. So I say you can stop right now, download Daily Dev into your browser, and we will aggregate all these magazines into one personalized feed. And we will deliver only the news you want to read with all the interesting stuff. So I really motivate you to try out after the talk. It's free for everyone, and looking forward to hear your comments. And if you want to hear how the Daily Dev feed works, so I want to introduce you to Alejandro from Tinybird, who is going to show you the engine behind Daily Dev. So please welcome Alejandro from Tinybird.
Hi, how are you, Ido?
Hey, I'm great. How are you?
I'm fine. Thanks for asking.
Excited.
Yeah, actually, because it's my first talk, so it's kind of exciting and stressful because I will do a live demo. So Let's see what it breaks.
Let's pray for the live demo god to be on your side. Good luck, Alejandro.
Thank you. I am Alejandro. I'm a data engineer at Tinybird. Tinybird is a platform that allows you to work with millions of rows, just like you will be doing with simple amounts of data. Really simple. You can be ingesting data from different sources. For example, we have integration with Kafka, with BigQuery, with Snowflake, S3, and we also have we support CSVs, Kafka, and JSONs. So really easily you can be ingesting all the data and then transform it using all simple SQL. And once you have run your query, that simple thing, you already have an endpoint. You just by clicking, you will be able to have an endpoint running over millions of rows in less than seconds. This being so flexible, it allows clients to do it's really flexible, so clients do all kinds of things, but mostly we could be categorizing in three main things. The first thing would be event processing and automation. For example, one of the cases, it would be Vercel. For example, Vercel, they track all the usage that the users are doing on their websites in order to know which is the pricing that they are going to be doing. Also, another thing is in product analytics. For example, in this case, also Vercel is doing that thing. If most of you already probably know Vercel, but if you go to Vercel and you have a website deployed over there, you can get analysis of how it's performing this website for all of the users. And this is being powered by Tinybird. Another case, for example, is the Hotel Network. In this case, you can read, if you go to our website, the Tinybird case study. Here we show how Tinybird was using MySQL and how they reach the limits, and how with Tinybird they are able to scale much faster, much better, much simple. Here you can see some of the stats, for example, how much we are scanning, processing, querying, and how many endpoints they have per everything per day. And the last one, it will be operationals. For example, in this case, some companies, they want to know how, for example, we have a big, huge retail company. They want to know how much they are selling, how much the stock they have, in which countries, how many returns they are getting. Because, for example, now in this Friday will be Black Friday, and they want to know if something is performing really well or really bad. Something I need to put it on the landing page or should I not? We really believe that speed wins, and real time it changed industries. And in the example, for example, for the retail, it was huge. It was super important, and now it's key for them. And for the demo, we are going to be actually powering a back office application of an e-commerce. So let's move to Tinybird. So once you sign up and you are in Tinybird, you will be seeing this thing. This is basically a workspace, an environment in Tinybird. Okay. In this case, we are going to be ingesting events coming from Kafka for that e-commerce. So if we go here and we say Ido rocks, we can be here, we can see a preview of all the data. Okay, so we are going to be ingesting all the data from that topic that has different types. For example, if we have some we have maybe some types for when someone bought something, when someone click an image, when someone returned something, different kind of things. So now we will start seeing how we are going to be ingesting all the data from Kafka. So we're going to rename this events. And now that we are going, see, we're starting already to ingesting 1 million rows. So now if, now that we have the data being ingesting in Tinybird, let's start working with it. One of the ways of working, the way to work with Tinybird is basically through pipes. Pipes is basically like a Jupyter notebook where you can write queries, and then just really simply, for example, we can write a query here where we say, okay, give me the 30, give me 30. And then here we can compose with the result of the previous one. And we can say, okay, give me the count. Well, in this case, it will be 30. But we can, this way it makes you really simple divide things in smaller things, in small SQLs. So it's much easier to know what is going on. Okay, so here I'm taking 30, here I'm doing the count, or maybe I'm doing a sum by the, let's go and see this thing, product types from that. So really simple, you can be splitting everything and making things much easy. So let's go in and create one endpoint. Okay, so here I have this. In this case, we're going to create a pipe where we're going to get the most clicked images. So we will call this endpoint and run this query. This is now running over 12 million rows and is taking 60 milliseconds to return. So now that we have this SQL and now we have these results, I mean, having the results here is fine, but you want to integrate it with your platform. You want to do something else. So we can just go here and create an endpoint. And there you go. Now you have an endpoint. Now we can use this any other place. Now maybe we want the front end to be attacking Tinybird, or we want the backend maybe calling Tinybird to get this information. But having the information just like this, it's fine, but it's a bit sad. It's static. It's not so good. Well, with Tinybird, you can do dynamic endpoints just by putting the keyword percentage. Now we can have dynamic endpoints. So let's go here and change the query. And as you can see, we added this thing. So this is a templating that we have that basically says, if we pass a product ID in the parameter, just filter it. And just like that, if we are going to be sending one, for example, let's take product 2, go here. Okay, we go here, and we put product ID product 2. We will be filtering by that. And see, we see it's taking 70 milliseconds. It's going really fast. If we go now, one of the key things also of Tinybird is the data flow. Now we can see how we have the events here and our endpoints that they are attacking this data source. But we also have a really powerful CLI. Let me change the screen 1 second. And now we should be able to see the terminal. Okay, so in this case, we have a repository where we have different data sources and different endpoints, okay? And finally, we have here something called pipes that is structured to do something else. It's not just endpoints. We will see in one few seconds what they are doing and all the power that they bring. So we will push this. In this case, we will throw everything, and if everything works fine, okay, we will see now that they are creating all the different data sources where we'll be storing things and different endpoints. So let's go back. Okay, this will take a while. And this, if we go here now to the data flow, okay, don't get scared. There is a lot of things, but it's fine, okay? So first of all, we just have here a basic data source that we will be using for the filtering, simple thing. Then here, some products that we added, some done products that we will use in the back office to have a visual thing. And now we can see that events, we have 37 million. We will be ingesting more and more, but for now, that's what we have. And then we have the previous endpoint that we had before. And we have a bunch of things here, okay? This is going to, this this and this and this. This will be, no, actually this 4, sorry, it will be the main endpoints that we're going to be using for our back office application. That is actually this one. Okay, in 2 seconds we will see how everything works. But as you may see here, we have something that this thing here, these endpoints, they look different than these ones. Well, actually, this is because this type of pipe is not just an endpoint pipe, it's a materializing pipe. What it's doing, this pipe here, is it's taking the data in real time, ingesting it, transforming it, and appending in this data source. This way, we can have the data pre-aggregated. For example, in this case, we are taking all the buy events and aggregating per date, per product type, device. So this way, when we are doing the query, we will be requesting less data and therefore going way much faster. As you can see, here we have 37 million rows, and here we just have 20,000. So let's go back to the application and see how now, with all the endpoints that we have created, how it will look like. Okay, so as you can see, now we have a bunch of things. So we have the filters here on the left that we just push, the products, and here is everything that we are selling. Okay, so as you can see, we can be moving through the different things. This is over the 37 million rows, and it's taking everything like 150. We can filter by the device, and you see everything is like going really fast. And this is the power that Tinybird brings. It makes you be able to analyze everything in real time, be able to query everything in a matter of seconds, and it goes super fast. And this is the power that has the materializations. The thing of being able to pre-aggregate all the information, be able to process all the 37 million rows and just have what you need, it's key for us. It makes, I mean, we can go a bit more to see how the pipes look like in these cases. Let's go to the get product sales. This would look like how a pipe will look maybe in a real world application. Here you can see the different parameters that we can be passing in the queries. And here we can see how we, in this case, we are attacking to the real time thing. And here we're attacking to the aggregation thing. Having the parameters, this allows us to filter dynamically. So when we want to have 1 month, we take 1 month. When we want to take 7 days, we take 7 days, and so on, so on. And therefore, after, when we can be checking, if you send me the parameter month or the week one, go to the aggregation. If not, go to the real one, to the real time one. And then now I'm going to show you a bit of the rules, how we approach things in Tinybird. So in Tinybird, we basically think that in order to make all these things go really fast, you need to always, this is the rules that we follow, like always try to not write the information. If you don't need that information, don't write it. The second one is, if you don't need it, don't read it. It's the best thing. But of course, it's not always the case. But the third one, the fourth and the fifth is the more important one, is basically everything have it by sorted. And the less data that you want to process, the way much better. That's why it's key for us and for Tinybird being able to do the materializations. And now also another aspect, in order to make this thing go as fast as these things, it's another approach that we follow in Tinybird. In Tinybird, usually in Tinybird, normally what you hear in all the time with data is, okay, no, you better define a model first, and then you put the logic above. For us, it's the other way around. We decide which it should be the logic, what we need to return, how the front end wants to retrieve these things, and then we can do the model, the data according to that. That's why the materialization are so important, because I have a raw data, then I aggregate it how I want to go. Okay, I will aggregate this by month, or by day, oh, this I'm going to do aggregation by device. And then this way I can do the queries over less data and go way much faster. And finally, I would just say that if any one of you have encountered problems with data and you have millions of rows that wants to be analyzed in times of 1 second, please sign up and just put your information and we will contact you. Currently, we are in beta, so we will be opening accounts small by small, but don't hesitate to contact. In any moment you have any questions or something, just please let us know. And we are working on making the product really good for everything and be integrating and being simple for developers. So if you also want to help us with that, there are open positions. Okay, so also if that's your passion, please let us know. And thank you for everything.
Thank you very much, Alejandro. It was a great introduction to Tinybird, and like my personal favorite feature of Tinybird is the fact that you are able to materialize data as soon as it gets in, rather than the traditional way. So this is the most powerful thing, I think, at least for our use case of daily.dev.
Yeah, I mean it's incredibly powerful because it allows you to have all the data aggregated. I mean I can just show again, for example, and see how you go here, and then let's see if now how many endpoints we have now, 36 millions. All this data is being processed now. For example, we are ingesting 2 million, 3 millions of rows now that we have from the Kafka topic. And if we go, for example, to any of these things, let's go here, for example. We go here, the endpoint. Oh, well, here we'll see. We should be able now to be seeing how things are increasing, but maybe there's too many things. We will not see it now, but that's true. I mean, it's incredibly powerful that the thing of being able to be ingesting and having everything. And one of the key things also I was saying of the templating, like for example, according to the parameters, okay, I want to get, for example, the last month. Okay, so I'm going to query only the data I have already aggregated by month, or this one by week, and it allows you to change everything however you want. Also, the analytical engine that we have, the database that we use, it's really powerful, and also that brings it helps a lot, but all the flexibility, it's amazing.
Yeah, I definitely agree. And for those of you who use daily.dev, so whenever you open a new tab or use our feed, just know that we use Tinybird to fetch all the articles. So thanks a lot, Alejandro. It was a pleasure.
I don't know if anyone has. Well, I just want to know if, in case someone has any question or wants to know anything more about Tinybird, you can write a comment, and I will be there. And just in case.
Okay, thank you very much. Bye-bye.
Bye.
Before we wrap up another incredible event of the monthly dev, I want to make sure and encourage you to like this video if you love the content that we provide, and subscribe our YouTube channel, Twitch, follow us on Twitter, whatever works for you. We are daily.dev everywhere on the planet, so just look us up on every platform. And we will be here in the next month, as always, with another great lineup. So stay tuned. We will open the registration very soon. So thanks a lot for coming, and see you soon in 1 month. Bye-bye.